simplifying rational exponential expressions. So this lesson will come from the video, from the worksheet that I gave out in class, and we decided to go over a couple of the problems dealing with simplifying rational exponential expressions. Okay, so the directions for all these problems are going to be to simplify. Your answer should contain only positive exponents with no fractional exponents in the denominator. So not only do we have to simplify each expression, but we also have to rationalize the denominator if we leave a fraction down there. So to refresh our memory, we can use all the properties of exponents to simplify my exponential expression. I know I am simplified when I have no more parentheses, no powers to powers, each base occurs only once, and no negative exponents and no zero exponents appear. Now, after I simplify every expression, I also must decide if I have to rationalize the denominator, right? No fractional exponents in the denominator, okay? So if I have to, I'm going to have to rationalize. Okay, so let's go over the 5 problems that we picked out in class today. And we're going to start each problem by deciding what is the most efficient way to begin. Like, how do I approach this problem? I see that we have a 2/3 exponent raising everything inside those parentheses to the 2/3 power. You could start there and multiply every one of those exponents by 2/3 and see what we get. I think it might be easier to simplify inside the parentheses first and then approach the exponent outside the parentheses. So let's do that. So let's start with the numerator. And there's nothing I can do there because we have an m and an n. Okay, but what we can do is we can combine the m's and the n's in the denominator, and then we can see where we can go from there. Okay, so first, I have an n to the first power. I have an n squared. Put those together. That's n to the third. And I have an n to the negative 1/2. So 3 minus a half gives me 2.5 or 5/2. So that's n to the 5/2 power. Okay. For the n, that gets rid of that because we've now accounted for it over here. All right. So I also like to do that while I'm going through these. Is like when I sort of put the variables together and I'm done with them, I kind of like to cross them out. That way, you know, I'm not confused and I know sort of what's left over. Okay. I got a positive 2. I got a negative 1/3. So 2 minus a third gives me 5/3. And remember, all this is still raised to the 2/3 power. Okay, so here's where we need to sort of decide what the most efficient thing to do is. I'm going to get one of every letter, and then I'm going to put the m's together, I'm going to put the n's together, and then I'm going to raise them to the 2/3 power. Okay, so I have a 4/3 and a 5/3. Luckily, they have the same denominator. That's nice. Okay, so I got to decide which one is bigger. That one is bigger. 5 is bigger than 4. So when I combine those and I subtract, I'm going to be left with m to the 1/3 on the bottom. Okay, so now with the n's, I'm also going to combine those two, and because this is negative, I'm going to move it down to the bottom of that fraction. So what I'm going to do is I'm going to get rid of this, and I'm going to put an n to the positive 3/4 at the bottom. Then I'm going to add these two together. So that turns into n to the 13/4, right? 5/2, 10/4, add to that. Nothing left on the top, and again, both of those to the 2/3 power, which means that I multiply. Power to a power, I multiply exponents. So my simplified answer is m to the 2/9 n to the, let's see what this is, 26/12, which is 13/6. Okay? So that is my simplified answer. Okay, just simplified, right? We didn't get to the other part yet. Okay, so how do I know it's simplified? Well, if I go back through my list here, right? No parentheses, no powers to power, each base only once, no zero or negative exponents. So that is true for this. It is simplified. However, we didn't follow my directions with no fractional exponents in the denominator. So this is always the first step. Get to the place where we have a simplified expression. Now we go one step further and rationalize it. Okay? So in order to rationalize it, I need the denominator to have no fractions. Well, 2/9 is a fraction. Okay, I want to make it not a fraction. So the next biggest whole number that is bigger than 2/9, because I can always multiply more stuff into this expression, but I can't really cancel anything out. There's nothing left to cancel, right? So I can't make my exponent go down, but I can make it bigger. Well, if I happen to multiply, and I got to multiply the top and the bottom by the same thing, by something that turns that exponent into the next biggest whole number, which is a 1, right? And if I just happen to multiply by 7/9, okay, now 2/9 times 7/9 gives me m to the first power, and then m to the 7/9 on top. Okay, let's do the same thing with an n. 13/6 is slightly bigger than 2. So for the n's, I'm going to multiply the top and the bottom by the thing that turns this into a 3, which is 5/6. And that gives me n to the third, n to the 5/6 on top. And that is my answer. Okay? So, to recap what we did in this problem, we combined stuff in the denominator. We moved stuff. We combined to have one of every letter. Then we tackled the outside exponent. Then we realized we had our simplified expression. And then we finally rationalized the denominator. All right, let's go to the next one. A lot of stuff going on here. There is, from what I see, right, we got the -2 out front. We got both of these raised to the 7/4. We got a lot of other fractions going on in here. All right, so let's handle inside the parentheses first, and then we'll tackle anything else. Okay, so what I want to do first is that stuff, because I might want to put m's and n's together. I might want to cancel something out, but I can't do it if it's raised to an exponent. Exponents come first. All right, and we'll tackle that one at the end. So this turns into 3/2. So that's 21/8, which is not reducible. Okay, so we are going to start with m squared n to the -3/2, m to the 21/8 power, and n, 2 times 7 is 14. 14/4 turns into 7/2. Bottom, m to the 1/2, n to the -1/2. Oops. And parentheses, all raised to the -2 power. Okay, well, let's start putting m's and n's together, and then we'll deal with the -2 at the end. Okay, so what do I got? I got a 2, I got a 21/8. Let's put those together first, and then I'll cancel out the 1/2. So 2 plus 21/8 turns into m to the 37/8, right? 216 plus 21. And well, let's do end. And they're nice and easy right there. They both have a denominator of 2. So that's 4/2, which is n squared, m to the 1/2, n to the -1/2. Okay. I can just cancel these two. Oh, both raised to the, don't forget this, still -2. Okay. I can cancel 1/2 with some over there. So 1/2 in terms of 8 is going to be 4/8, which gives me m to the 33/8 power. And then I'm going to take this and move it to the top of the fraction to make it positive and give me n to the 5/2 power. Okay? And now neither one of those are in a denominator for now, but because of this -2, let's think about how we want to handle this -2 exponent. Okay? I can move both of these to the bottom of a fraction and make that exponent positive, or I could distribute the -2 exponent to both of those and then move them at the end. Either way, you should get to the same spot. All right, let's just do this. Let's just put this on the bottom of a fraction, m to the 33/8, n to the 5/2 power, and now we're both raised to the +2. Okay, which gives me 1 over, right, whoops, times 2 gives me m to the 33/4 power and n to the 5th. Now, I am allowed to leave whole number exponents in the bottom, but not fractional exponents. So let's bring this over here. 1 over m to the 33/4 n to the 5th. I'm going to multiply the top and the bottom by something that turns 33 into the next biggest exponent. Well, 32 is divisible by 4, so that doesn't help. And 36 is divisible by 4 9 times. So if I can only had a 36 there, and I can make it a 36 by putting 3 more. Whatever I do to the bottom, I have to do to the top. And my answer becomes m to the 3/4 power. On the bottom, we have m to the 36/4, which is 9, n to the 5th. And that is my answer that is now rationalized. Okay? So again, this was the simplified version, but it's not rationalized. So we have to take it that one extra step and rationalize the denominator. No roots in the denominator. And remember, this is the 4th root of m to the 33rd power. Okay? Let's try this one. 8. Well, immediately, good starting point. Not this. Okay? The x is not raised to the 0 power. Only the y's. Okay? Where would I go from here? I'd probably tackle this exponent first, and then this exponent, and maybe cancel x along the way. All right, so let's do that. let's handle this set of parentheses. So we start with x to the negative 1/2 times positive 3 over 2. Gives me negative 3 over 4. Y to the negative 12 over 6, which is negative 2, over x, all raised to the negative 2 power. Okay, now usually what I like to do is simplify the inside first before I tackle this outside exponent. Okay, so let's go ahead and do that. Yeah, okay, so negative 3 over 4, that's a positive 1. We can bring down the 3 over 4, and I get x to the 7 over 4. And y, I could move it down here to make it positive, but I'm just raising it to a negative 2 power. Let's leave it up here for a second, and let's do something different with this negative exponent. Okay. The different thing that I can do is, I'm going to go down here, is that if I flip this fraction, if I put whatever is in the denominator in the top and whatever was in the numerator in the bottom, this exponent then turns to a positive 2. Okay? And then I can move this y up if I wanted to. I can just distribute the exponent right now. So that's 14 over 4, which turns into 7 over 2. So that's x to the 7 over 2. Y becomes negative 4, and it just pops up to the top to be a positive 4. It is okay to have fractions, fractional exponents, as long as they're not in the denominator. This expression has no more denominator because what I really did was move this up like this before I squared it. So we're done. No negative exponents, no fractional exponents in the denominator, and we are simplified with one of every letter. Okay? All right, so we got a couple more. 12. First step, right there. Get rid of it. 0 exponents, get rid of it. All right? Again, I think simplifying inside the fraction before raising everything to the 4 over 3 power is probably easier. Okay? And this one is going to have some crazy fractions in it. So let's not make them any crazier before we actually have to. All right, so let's start off with the top, u to the 5 over 4 power, v, negative 1/4. Let's leave that there for a second. Let's just put the v's on the bottom together and see where we are. So we have 7 over 4 and the 5 over 3 to give me 41 over 12. So that would be v to the negative 41 over 12, right? I just added these two together, common denominator 12. U to the 3/4. U's are easy to see here. Top's bigger than the bottom. Okay, so subtract. 5 over 4 minus, cancel out the 3 over 4 with 5 over 4 here, and we're left with 2 over 4 on the top, which is 1/2. This one, I'm going to move this one to the top. Why am I going to move it to the top? Because it's way bigger than a quarter, and that way I'm going to have a positive answer in the top. And I don't lose the 4 over 3 right here. So that's v to the negative 1/4 plus 41 over 12. So 41 over 12 minus 1/4 gives me 19 over 6. Okay. Yeah, good. Look at that. Nothing left in the denominator. Now all I have to do is raise them both to the 4/3 power, and I don't even have to rationalize everything because I managed to get everything out of the denominator already. There's no more negative exponents. There's one of every letter. We just got power to a power. So u to the 1/2 times 4/3 is 4/6, which is 2/3. V becomes 76/18, which reduces to 38/9. Multiply, multiply, and then just reduce the fraction. All right, so what started out that looked like a kind of crazy problem actually worked out not too bad, especially considering we did not have to rationalize anything in the denominator. Looks like the same thing is going to happen here, especially because I can start like that. Okay, let's do that last. Let's do this first. Okay, so hopefully you see a little bit of my approach here is I want to tackle the inside parentheses first, because then I can combine it with this thing, and then I can do the exponent outside. So this turns into x to the negative 3/4, y to the negative 4/6, which is 2/3, y to the negative 1. Nothing left on the bottom, so I didn't even need this fractional bar because I canceled out that. All raised to the negative 4/3 power. Couple approaches here. Again, we can make this a positive 4/3 by moving everything to the bottom of a fraction. We can, or in essence, flipping it over. We can put these all on the bottom of a fraction first and then raise them to the negative 4/3 power, but that's just going to make them negative again. The better idea is just to distribute this exponent to all these exponents. We can even put these together first, because the negative is just going to cancel out and be positive. So what I want to do is, let's put these two together before I even do that. So x in the negative 3/4, and then y becomes 5/3, so negative 4/3. Power to a power, you multiply. 3/4 times 4/3 is 1. That's nice. 20/9 does not reduce, and that's the answer. It is simplified. No need to rationalize. And now we have our answer. Okay, so I could have done more right here, but it seemed to me to introduce more complexity to something that would have cleaned itself up naturally. And how did I know it was going to clean itself up? I didn't really, but looking at it, I see all these negative exponents multiplied together with another negative exponent is just going to have the effect of making them positive. Okay, so while it is a good idea to have positive exponents inside of the parentheses before you do the thing on the outside, you might want to check to see you're not going to make the problem harder in the end. And I think this was the last one that we picked in class. And again, this one is not going to be too bad. It looks like it looks like I'm not going to have to rationalize the answer. Okay. So I would start here on the top. Let's take care of these parentheses. Then let's clean up the bottom, and then let's see what cancels out and what I can do. So power to a power, multiply. So we have x to the negative 5/6. Right, multiply. Y to the negative 10/9 over um, we can put those two together right like that. So we need a common denominator, which is 12. So 5 over 4 and 5 over 3 give me 35 over 12. So that's negative 35 over 12. These two go together. A little bit easier there. Common denominator is 2. So that's negative 2.5, negative 5 over 2. Okay. Well, I see a lot of negative exponents. I can move them all around and make them positive, or I can think to myself, which one of these is bigger? Well, this is almost 3. This is 2.5. Both these are less than 1, or this is a little bit bigger than 1, but not much. Okay, so these two numbers are smaller than these two numbers. So if I take these two and move them to the top and make them positive, then I combine them with these two, my answer should be positive exponents. So really what I'm doing is x to the negative 5 over 6, x to the positive 35 over 12, y to the negative 10 over 9, y to the positive 5 over 2, right? I moved those two things to the top of a fraction to make the exponents positive. Now I just put these together, which gives me common denominator of 12, so that's minus 10, so that is 25. So x to the 25 over 12, y, common denominator 18, so we're going to have to mess around with this one a little bit, but we get a 25 as well over 18. Okay, so again, no need to rationalize this denominator, right? We just simplified everything and we were left with expressions, with an expression that did not need to be rationalized. Okay, I feel like the last couple that we picked didn't really have anything that we needed to rationalize. So let's go back one, and I didn't actually prepare this one, but this would be number 19. And we have m to the 0 to the 1/4 power times m to the 1/3 n to the negative 2 all to the negative 2 power over m to the 1/2. So I just wanted to pick one more problem that you have to rationalize the denominator. And to start, look at that. Isn't that nice? Okay, so instead of moving this whole thing around, let's just distribute this 2, because moving it, there's one positive, one negative. There's still going to be one positive, one negative, even if I move it. So don't make things more complex if you don't have to. So this turns into m to the negative 2 over 3, n to the positive 4 over m to the 1/2 power. Okay, let's take this and move it down. Okay, make it positive and combine it with the 1/2. So now we have n to the 4th power over m to the 1/2 n to the 2/3, sorry, m to the 2/3. Okay, so common denominator of 6 gives me 1/2 plus 2/3 gives me 7 over 6. Okay, so I got 1 over every letter. I'm simplified, no powers to powers, no negative exponents, no zero exponents. This is a simplified expression. The problem is it has a fractional exponent in the denominator, so I need to rationalize. And the way I do that, okay, so here's my answer. It's going to be n to the 4th with something, right? Because this one's done. I don't need to do anything with the n. It's just n to the 4th. So I need to multiply by something that'll make 7 over 6 not a fraction. Okay, so I need another 5 over 6, because that would make 12 over 6. which is m squared. There's nothing with the m to multiply with, so we just leave the 5/6 on the top. And now that it is both simplified and rationalized. So that's it. That'll be the last problem. Hopefully, after watching some of this, most of your questions about how to simplify a rational expression, a rational exponential expression, have been answered. It's kind of just working with fractions, right? You just have to be able to take these fractions, combine them with other fractions, be careful of the denominator, or be careful of the common denominators when you put them together, be careful of the signs, and then just realize like what you're trying to accomplish. You're trying to get simplify first, then decide if you need to rationalize later. Okay. Hope this helps.